Hello everyone, good evening. So here we shall start the third part of this video on ray optics and optical instruments. We shall solve some previous year KCET questions. So any doubts you have in any of the steps, then please write us in the comment section, and please install our Sapience education application, where we shall upload some important homework questions on every chapter. And in any other chapter which you feel more difficulty, then please write the name of that chapter in the comment section. Then we shall give more priority on it and solve more questions on that chapter. So here in this, in the first two parts we had solved in question number 25. So here we shall solve from question number 26 onwards. So here monochromatic beam of light is traveling from medium A of refractive index n1 to a medium of refractive index n2. In the medium A, there are x number of waves in certain distance. In medium A, there are x number of waves in a certain distance. In the medium B, there are y number of waves in the same distance. Refractive index of medium A with respect to medium B, that is how much? Okay. So wave number is 1 by lambda. So we know that n1 by n2 is how much? So n1 is equal to c by v1. v1 is equal to lambda 1 into nu, and v2 is lambda 2 into nu. Since it is monochromatic, so its frequency will remain unchanged when the medium changes. So only the wavelength will change. And n2 is c by v2. So therefore n1 I can write. So this I can write nu by the lambda is 1 by nu bar. Nu bar is the wave number. So nu by nu1 bar, this is nu by nu2 bar. So n1 is c by v1, is nu by nu1 bar, and n2 is also equal to c by nu into nu2 bar. So therefore n1 by n2, that is equal to nu1 bar by nu2 bar. So this is only equal to the wave number, that is x by y. So therefore, the refractive index of medium A with respect to medium 2, that is n12, that is x by y. So option D is the correct answer. Then it's told that frequencies of light incident on a system of scattering particles are in the ratio 1:2. In the intensity of scattered light, a particular direction is frequency of light The system of scattered particles are in the ratio 1:2. Frequency nu1 by nu2, that is equal to 1/2. And the intensity of scattered particles in a particular direction is. So intensity is inversely proportional to lambda power 4. So we know that C is equal to nu into lambda. So lambda is equal to C by nu. Therefore, I can say that the intensity is directly proportional to the fourth power of the frequency. So therefore, the frequency is in the ratio 1:2. So therefore, the intensity of scattered particles will be in the ratio I1 by I2, that is nu1 by nu2 whole power 4. So that is 1/2 whole power 4, that is 1/8. So the ratio is 1:8. Option C is the correct answer. Okay, sorry, it is whole power 4. So 2 power 4, that is 16. So 1:16. So option D is the correct answer. Then question number 28, it is told white light is incident normally on a glass slab. White light is incident normally on a glass slab. Inside the glass slab, red light travels faster than other colors. So red light travels faster than other colors. So we know that the wavelength of red is the highest. So the frequency, so the refractive index for red is the least. So the speed of the red light is the highest. So red light travels faster than other colors. So option A is the correct answer. Question number 29 is that take out the wrong statement from the following. Lateral shift increases as the angle of incidence increases. Normal shift decreases as the value of refractive index increases. Lateral shift increases as the value of so the lateral shift in a glass slab that lateral shift in a glass slab that is equal to T sine I minus R by cos R. t sin I minus r by cos I. So when the angle of incidence increases, then the angle of refraction also increases. So cos r decreases. So the value of the lateral shift. So lateral shift is t sin minus cos I into okay, so the lateral shift can be written as like this: t sin I into 1 minus cos I by square root of mu square minus sin square. And the normal shift is given as t into 1 minus 1 by mu. So when the normal shift increases as the value of refractive index. When the refractive index increases, then the normal shift decreases. Refractive index increases, then 1 by mu decreases, so the lateral shift increases. No, so the normal shift increases. So it means that B is correct statement, but C is the wrong statement. So option C is the correct answer. Then in question number 30, it is told the refraction through the prisms are as shown. Pick out the wrong statement from the following. Path of the light ray is one is so 30 n2 is greater than n1. n2 n2 this is n1 is n3. So if n2 is greater than n1, it will bend towards the normal, and n3 is less than n2, then it will bend away from the normal. So first, so then the first one is wrong. It is not always true. So it will, the first case will happen only if on the second surface the angle of incidence is at the critical angle. The angle of incidence is equal to the critical angle on the second surface. Then only this thing will happen. That is, there will be the angle of refraction is 90 degrees. And in the second case, second option is correct if n1 is equal to n2 and n2 is greater than n3. n1 is equal to n2, n2 is greater than n3. n1 and second one. So first one can happen. Okay, first one can happen in some special cases. So in the second one can happen only if n1 is equal to n2, then there is no refraction, and n2 is greater than n3 means the refracted ray will bend away from the second one. B option is also correct statement. A is also correct statement. And the option C, 3 is correct if n2 is less than n1. If n2 is less than n1, then n2 is less than n1, then it will bend away from the normal. It will be like this. So third one is wrong. That means that option C is wrong, and option D, fourth one is correct if n1 is greater than n2. So if n1 is greater than n2, it will bend towards the normal. So n1 is greater than n2, so n2 is less, so it will bend away from the normal. It will be like this. So option D is also the wrong statement. So we have to choose the wrong statement. So D, C and D are the correct answers. Then in question number 31, it is told the distance between an object and its real image produced by a converging lens is 0.72 meters. The magnification is 2. What will be the magnification and the object is moved by 0.04 meter towards the lens? The distance between an object and its real image produced by a converging lens so converging lens means it is convex lens. The distance between an object and its real image, that is inverted, that is 0.72 meters, means it is 72 centimeter. Magnification is 2. What will be the magnification when the object is moved by 0.04 meter towards the lens? Object is moved by 0.04. So by 4 centimeter, it is moved towards the lens. So this is x, so v is 72 minus x. Therefore, I will use 1 by v, that is 72 minus x, minus 1 by u. U is x. U is minus x. So that is equal to 1 by f. So here it is told that v by u, m is equal to v by u, that is equal to 2. So therefore, v is equal to 2u. So therefore, 72 minus x, that is equal to 2x. So this will be 3x, that is equal to 72. So therefore, x is equal to 6 is equal to 24. This will be 1 by 72 minus 24, that is 8, 3, 4, 1 by 48 plus 1 by 24, that will be equal to 1 by f. So this will be 3 by 48, that is equal to 1 by f. So f is equal to 16. Focal length is 16 centimeter. What will be the magnification? It is moved by 4 centimeter towards the lens. So therefore, we can say that it's moved by 4 centimeter towards the line. So now the new value of u is 24. So this will be minus 20 centimeters. So v will be how much? That will be fine. Will be the magnification. So 1 by v minus 1 by u, that is equal to 1 by f, that is 16. So 1 by v plus 1 by 20, that is equal to 1 by 16. So 1 by v will be equal to 1 by 20 minus, sorry, 1 by 16 minus 1 by 20, that is 2. So the LCM is 80. So 16 5 is 80 minus 24 is 80. So this is 1 by 80. So v is equal to 80, and therefore the new value of the magnification m dash, that is new value of v by value of v, that is 4. So option B is the correct answer. And in question number 32, it is told that the speed of light in media M1 and M2 are speed of light in media M1 and M2 are 1.5 into 10 power 8 meter per second and 2 into 10 power 8 meter per second. A ray travels from medium M1 to medium M2. So in medium M1, the speed of light is less, so it is optically denser. It means that its refractive index is higher. And for M2, the refractive index is lesser, since the speed of light is higher in light. So it is optically rarer. Its refractive index is low. So refractive index of medium 2 is less than the refractive index of medium 1. So when it is going from denser to rarer, the light ray will bend away from the normal. A ray travels from medium M1 to M2 with an angle of incidence theta. So here I is theta. The ray suffers total internal reflection. So the ray suffers total internal reflection. Means that it will reflect. The ray, then the value of the angle of incidence theta is. So we know that if I is greater than the critical angle, then there is total internal reflection. There is Ti. So here, if we find the critical angle of incidence, here we should have, suppose here it is, the refractive index is mu1, for medium 2 the refractive index is mu2. So the refractive index of medium 1, that is mu1, that is how much? C by V, V1. So C is 3 into 10 power 8 meter per second by V1 is 1.5 into 10 power 8. So that is equal to 2. And the refractive index of medium 2, that will be C by V2. So that will be 3 into 10 power 8 by 2 into 10 power 8. That will be equal to 3 by 2. So that will be equal to 3 by 2. And then if we have to find the critical angle of incidence, then here we can say that mu1 is greater than mu2. I will say that mu1 into sine IC, that is equal to mu2 into sine 90. So therefore sine IC is equal to mu2 by mu1. So that will be 3 by 2 by 2. That is equal to 3 by 2. Therefore, I see the value of the critical angle, that will be sine inverse of 3 by 4. So therefore, here the value of this angle of incidence theta should be more than sine inverse 3 by 4. So option B is the correct answer. Sorry, theta should be greater than sine inverse 3 by 4. So option A is the correct answer. Then in question number 33, it's told the radii of curvature of a converging lens are in the ratio 1:2. Its focal length is 6 cm and effective index is 1.5. Then its radius of curvature r. So suppose its radiuses of curvature are r and 2r. So then therefore I can say 1 by f, that is equal to mu by the refractive index of the air So refractive index of that converging lens by refractive index of A minus 1 into 1 by R plus 1 by 2R. And this is equal to 1 by 6 centimeter inverse. So therefore 1 by 6, that will be equal to this 3 by 2R into refractive index 1.5 by 1 minus 1. This will be 1 by 6, that is equal to 3 by 2R into 1.5 minus 1, that is 0.5, 1 by 2. So 4R by 3, that is equal to 6. That is equal, that is equal to 6. So R is equal to 6 into 3 by 4. So 2 to the 4 to 3 is 6. So R is equal to 9 by 2. R is equal to 9 by 2. So therefore, the radius of curvatures are, one is 4.5 centimeter and the other is 9 centimeter, which is 2R. 2R is 9. So option D is the correct answer. In question number 34, stored an object is placed at 40 centimeter in front of a concave mirror. An object is placed at a distance of 20 centimeter in front of a concave mirror, and produces 3 times magnified real image. What is the focal length of the concave mirror? Object is placed 20 centimeter in front of a concave mirror, which produces 3 times magnified real image. So the magnification is so it is a real image, so the magnification should be -3. Since for real image it will be inverted. The focal length of the concave mirror is how much? So here u is -20 centimeter and v is -60 centimeter. The focal length is 1. Since m is equal to minus v by u, which is equal to -3, so v is equal to 3. So therefore, for mirror, we should have 1 by v plus 1 by v that is equal to 1 by f. So 1 by v is -60 centimeter plus 1 by u that is -20 that is equal to 1 by f. So -1 by 60, then -3 by 60. So that is equal to 1 by f. So 1 by f is -4 by 60. So it is 15 for the 60. So f is -15. So this negative sign represents that it is a concave mirror. It's concave mirror. So the focal length is 15 centimeters. So option D is the correct answer. Then in question number 35, it is told a focal length of a lens is 10 centimeter. What is the power of the lens in diopters? Focal length of the lens, that is 10 centimeter. What is the power of the lens in diopters? P is equal to 1 by f, but in meters of use. So 10 centimeter is 0.1 or 1 by 10 meters. So the power of the lens will be 10 diopters. 10 diopters. So option D is the correct answer. Then it's told that a microscope is having objective of focal length 1 centimeter. A microscope is there. Is having an objective and the eyepiece. The focal length of the objective is 1 centimeter and the focal length of the eyepiece, that is 6 centimeter. If the tube length is 30 centimeter, so tube length is n equal to 30 centimeter, and the image is formed at the least distance of distinct vision, then the magnification produced by the microscope is how much? Take D is equal to 25 centimeter. So the least distance of distinct vision, capital D, that is 25 centimeter. And the tube length of the microscope L, that is 30 centimeter. So when the image is formed in the least distance of distinct, so we know that when the image is formed, when the image is formed, the image is formed at the least distance of distinct vision, the least distance of distinct vision, then the magnification produced by the microscope is given as the magnification produced by the microscope M, that is given as L by F naught into 1 plus D by F. L by F naught into 1 plus D by F, which is equal to 30 by 1. Thirty centimeter by 1 centimeter into 1 plus 25 centimeter by 6 centimeter. So this will be equal to 30 into 1 plus 25 by 6, that is 31 by 6. So 30, so this is 155. So which is close to 150. So option D is the correct answer. So it means here you have to choose the closest answer. Calculate the focal length of a reading glass of a person if his distance of distinct vision is 75 centimeter. So the least distance of distinct vision, that is 75 centimeter. Calculate the focal length of the reading glass. How much should be the reading glass? Okay, so it means that at the least distance of distinct vision, which is actually 25 centimeter, the image of that should be formed on at 75 centimeters. So it means that one convex lens should be used, so that the image which is at 25 centimeter, means the object which is at 25 centimeter, he should be able to view it at plus 75 centimeter also. So you should be able to, so the convex lens should form the image of the object here. So this one is B. This one is B. Therefore, U is how much? U is minus 25 centimeter and E is minus 75 centimeter. The focal length should be how much? So I can say that 1 by V minus 1 by V, that is equal to 1 by V. So therefore 1 by V, that is by minus 75 plus 1 by 25, that is equal to 1 by V. So 1 by F will be 1 by 25 minus 1 by 75. So this will be equal to, so 25 3 is 75. So this will be 2 by 75. Therefore, so this is 2 by 75. So the focal length, so it should be 75 by 2. That is 37.5 centimeters. So option A is the correct answer. Then in question number 38, it is told a person wants a real image of his star 3 times enlarged. Where should he stand in front of a contour mirror of radius of curvature 30 centimeter? The radius of curvature is 30 centimeter. So we know that that is equal to 2f, twice of the focal length. So the focal length is 15 centimeter. So here the object is there. This is u. Then the image should be found here. Okay, this is v. And the focus should be somewhere here. So the focus should be here. And the magnification m, that is minus b by u, that is equal to 3. So b is equal to minus 3. So u, so suppose u, I can take it as minus x, means where x is the required answer, where it is also x is the distance from the mirror, where he should stand. Then therefore b is equal to 3x minus of x. V is also minus 3x actually. Sorry, here the figure is slightly wrong. V should be somewhere here. The image should be found somewhere here. So it is a virtual image which is found behind the mirror. Virtual image which is found behind the mirror, which is 3 times enlarged. So the V is this. So V should come positive. So this is 3x. V is 3x. So therefore, right. And for concave, here the focal length is negative. Focal length is, so therefore I can say that 1 by v plus 1 by u, that is equal to 1 by f, which is the mirror equation. So therefore 1 by v is 3. So v is equal to 3x. So 1 by 3x, then u is minus x, so it is minus 1 by x, that is equal to 1 by f, which is 1 by minus 15. So then we can say that 1 by x minus 1 by 3x. X minus 1 by 3x, that is equal to 1 by 15. So I can say that, so this is 3 by 3x. 2 by 3x is 1 by 15. So 3x by 2, that is 15. 3x by 2, that is 15. So x is equal to 22 by 3. So that's 15. So x is equal to 10. It's equal to 10 centimeter. So option C is the correct answer. So how far should he stand? X. So C is the correct answer. Then in question number 39, it's told that if epsilon naught and mu naught are the permittivity and permeability of free space, and epsilon and mu are the corresponding quantities for a medium, then the refractive index of the medium is. So we know that refractive index mu of the medium, sorry, refractive index n of the medium, that is equal to c by v. So that is equal to now E is equal to 1 by square root of mu naught into epsilon naught. Square root of mu naught into epsilon naught. And the speed v in any other medium, that will be 1 by square root of mu into epsilon. So now n we can write it as c, 1 by root over mu naught into epsilon naught divided by 1 by root over mu into epsilon. So this will be equal to root over mu into epsilon divided by root over mu naught into epsilon. So this is the required refractive index. So option A is the correct answer. In question number 40 is told a plain glass plate is placed over a various colored letters. A plain glass plate is placed for various colored letters, which is violet, green, and then yellow and red. The letter which appears to be more raised, that is one. So we know that the apparent depth of the object, that is equal to d by mu relative. So it will be the refractive index of the glass by refractive index of air. So this will be d by 3 by 2. So that is 2d by 3. No, sorry. So this is d by mu, and mu, that is, so wavelength is highest for red. Wavelength for red is highest. So the refractive index for red is the least. Refractive index for red is the least. So the apparent depth, which is d by mu, that is highest for red. apparent depth is highest for red, and so it means that the wavelength of violet is the least. So the refractive index for violet, that is the highest. For the refractive index for violet is highest, so the apparent depth for violet is the least. Apparent depth for highest apparent depth is least for violet. So it means that the letter which is in violet, that will appear to be more raised. So the violet colored letter will appear to be more raised. So option D is the correct answer. Then in question number 41, it's told that a ray of light passes through 4 transparent media with refractive indices n1, n2, n3, and n4 as shown. A ray of light passes through 4 transparent media with refractive indices n1, n2, n3, and n4 as shown. The surface of all media are parallel. If the emergent ray DE is parallel to the incident ray AB, then a ray of light, if the emergent ray DE is parallel to the incident ray AB, then n1 is equal to n4. Simply, it means that when the refractive indices are same, then the angle of incidence will be equal to the angle of refraction. So if we apply the Snell's law, it's n1 is equal to n4. Option A is the correct answer. In question number 42, is told the focal length of a convex lens is 20 centimeter and its refractive index mean, that is 1.5. It produces an erect enlarged image if the distance of the object from the lens is. So we know that if the magnitude of u is less than f, then we have a virtual and erect image. Virtual and erect and enlarged image. Virtual, erect, and enlarged image for a convex lens. So now magnitude of u should be less than 8. So magnitude of u should be less than 20 centimeters. So only option C is less than 20 centimeters. So the option C is the correct answer. So if we keep the object at a distance of 15 centimeter from the lens, if we keep the object at a distance of 15 centimeter from the lens, then we will have a virtual erect and enlarged image. Question number 43 is told a ray of light suffers a minimum deviation when incident on an equilateral prism of refractive index √2. A ray of light suffers a minimum deviation. Ray of light here. A ray of light suffers a minimum deviation incident on an equilateral prism. Equilateral prism means the angle of the prism is 60 degrees. A ray of light suffers minimum deviation. The angle of incidence, that is how much? Asked. So when there is minimum deviation, then we have R1 is equal to R2. Here this is R1 and this is R2. This is E, angle of the emergence, and this is angle of incidence. So R1 is equal to R2, that is equal to A by 2. And I is equal to E. So I can say that R1 is equal to R2 is equal to 30 degree. And the refractive index mean, that is √2. So therefore I can say that if I apply the Snell's law here outside there is air. So I can write refractive index of air into sine I, that is equal to refractive index of the prism into sine R1. So therefore we will have refractive index of air, which is 1 into sine I, that is equal to refractive index of prism, that is √2 into sine R1, that is sine 30 degree. So sine I, that is equal to √2 into half, that is 1 by √2. Therefore I will be equal to 45 degrees. Option B is the correct answer. Option B is the correct answer. And in question number 44, it's told during scattering of light, the amount of scattering is inversely proportional to the fourth power of wavelength. We know that the intensity of scattering is inversely proportional to the fourth power of the wavelength of light, which is called the Rayleigh scattering. Or I can say it is the Rayleigh's law of scattering. Here in question number 45, it is told, according to Cartesian sign convention in ray optics, all distances in the direction of the incident ray are taken positive. Yeah, option A is correct. All distances are taken negative. No, it is wrong. All distances in the direction of incident ray are taken negative. No, it is wrong. All distances are taken positive. It is also wrong. So option A is the correct answer. That in the direction of the incident ray, the direction of the incident ray is always taken positive. Always taken positive. So this is the Cartesian sign convention in ray optics. So then question number 46, it is told that a linear object of height 10 cm is kept in front of a concave mirror of radius of curvature 15 cm at a distance of 10 cm. So the radius of curvature is 15 centimeters. So therefore, concave mirror is there. Radius of curvature is 15 centimeters. So the focal length is r by 2. That is 7.5 centimeter. And the linear object of 10 centimeter height is kept at a distance of 10 centimeters here. So 2f is how much? 2f is 15. So this is 2f, means this point is the center of curvature, this is the focus, and here we have the object. Here we have the object AB. So it is kept in between f and 2f. It's kept in between f and 2f. So it means the image which will be formed, that will be real, inverted, and enlarged, and that will be formed beyond the center of curvature. So the image is magnified and inverted. Image is magnified, and image is magnified and inverted. Obviously, since y here b is more than u, so when you do m is equal to b by u, then the magnitude of that m, that will be obviously more than 1. So here if we want, we can solve also. Here u is, this is u, that is 10 centimeter. This is the focal length, that is 7.5 centimeter, and the center of curvature is at a distance of 15 centimeter from the pole of the mirror. So this is v, this we have to find. So actually this is magnitude of v, the length. Since length cannot be negative, but v will come negative. So u is here minus 10 centimeter. The focal length is minus 7.5 centimeter. So then you can say that 1 by v plus 1 by u, that is equal to 1 by f. So therefore 1 by v minus 1 by 10, that is equal to minus 1 by, this is 15 by 2. So therefore 1 by v, that is equal to 1 by 10 minus 2 by 15. So this will be 15 tens, this is 30, 3 10, 30, 15, 2 by 34 plus 4. So this is minus 1 by 30. So v is equal to minus 30 centimeters. So therefore the magnification value, that is equal to v by u, that is coming 3. So the image is 3 times enlarged. So it is be obviously magnified and inverted. So option B is the correct answer. Then in question number 47, it is told that an object is placed at the principal focus of a convex mirror. An object is placed at the principal focus of a convex mirror. So here the focal length is positive and u is equal to minus f. So therefore, how will be the image? So here also 1 by v plus 1 by u, that is equal to 1 by f. So this will be 1 by v minus 1 by f, that is equal to 1 by f. So 1 by v, that is equal to 1 by 2f. So v is equal to 2f. So the image will be formed here. convex mirror. So is equal to 2f. So it will form at the center of curvature. It will form. It is placed at the principal focus. So the principal focus, if it is placed, then it means. So the principal focus is here actually. So it means that a virtual object is placed here. So E is equal to F, and the focal length is also F. So here 1 by V minus 1 by plus 1 by E, that is equal to 1 by F. So I will do 1 by V plus 1 by F, that is equal to 1 by F. If F will 1 by F will cancel. So 1 by V equal to 0. So it means that V is equal to infinity. It means the image is formed at infinity. Option C is the correct answer. Okay, so here we shall end the third part of this video on ray optics and optical instruments, which is based on the previous year's KCET exams. So hope all of you have understood all the steps of the solutions of these 47 questions which you had solved in these first 3 parts. So any doubts you have, then please write us in the comments section, and also install our Sapience Education application, where we shall upload some important homework questions on the previous year KCET exam, which shall be helpful for your KCET exam. So thank you everyone.